Okay, another example here. An ABC phase sequence, three-phase balanced Y-connected source supplies power to a balanced delta connected load. So the load is delta. So my load looks like this. It doesn't really matter if I flip it. That's what my load looks like. It's 14 plus 7J. Well, this is 14, this is the 7J. This is the 14, this is the 7J. And right here, 14, this is the 7J. And my source is a Y source. We always try to match them. It's easier if you match them, if you make them the same. What probably I'm going to do is take this one, break it down to, we call this, I don't know, Z1, Z2, and Z3. Change it to Y. But since that's a balance, that means Z1 is going to equal to Z2 is going to equal to Z3. And the way you find each one of them, like if you want to find Z1, you take this one, multiply it by this, and you divide it by the sum of them. So that'll be 14 plus 7J. That's this one here, times this one here. You can go back to last semester and look and see how we did them. Divided by the sum of all three of them. But when they're balanced there, once you find one, it's going to be the same for all of them. This is plus, plus. And if they're really equal, if you think about them, let's call each one of them Z. That'll be Z times Z over what? 3Z. And what do you know? It's Z over 3. So really, each one of these is going to equal to what? Which equals Z over 3, and that's 14 plus 7J divided by 3. And if you divide 14 by 3, that's what? 4.67. 7 divided by 3 is what? 2.33. That's what each one is. So once you have that, you can draw one phase of that. You go, here's my VAN. And here's my load of 4.67 plus J 2.33. This is my A. This is lowercase a. Uppercase N, that's the load, lowercase n. And I'm looking for I sub AA. We know what VAN was given to us to be what? 120 angle 80. So quick math here. You'll have I sub AA is equal to 120 angle 80 divided by what? 4.67 plus J 2.33. And what do you have? You have 23 angle roughly 53 degrees RMS amps. And what's I sub BB? 23 subtract this is an ABC, so 53 minus 120, what is it? 53, clear? 53 minus 120, negative 67 degrees. And I sub CC is going to be 23, subtract another 120 from this, negative 187 degrees. Or plus 173. And that's the end of this problem. That went by quickly, so I have another one ready for us. So let me put another one here. There we go. I'll give you a chance to read the questions before we go over it. What we have is a balanced three-phase Y to Y system. That means Y source, Y load. The source is ABC sequence set. So here's what we have. We have VAN here. We're not sure what that value is. But now this is the first time, I don't remember doing an example, where the line itself here, it has an impedance. 1 plus 1j. So the line is not a perfect line. So this is capital A. And now this is 14 and 12j. And this is capital N. Well, we know that this voltage here, AN, that means plus to minus, right there, is 440 angle 30 degrees volts RMS. And the question, can you find what VAN is? Because if you know what VAN is, you know what VAB. Well, since this is one branch, so the current going through that, I sub AA, is the same current going through this, I sub AN. So I sub AA, it is actually the 440 angle 30 volts RMS, and you divide that by 14 plus 12j. And if you do the math there, that's 23.9 angle negative 10.6 amps. Was that RMS? Yep, RMS. Well, what's going to happen? As this current going through is going to mark this plus to minus. So there's a voltage drop here. So VAN is going to be the 440 angle 30 plus the voltage drop here, which is what? 1 plus 1j times the current going through it, and that's 23.9 angle negative 10.6. And VAN, if you do the math, is 473.7 angle 30 point, was it 3 degrees? If you want to find VAB, as I said early, you want to take the 473.7 multiplied by the square root 3 and add 30 degrees to that angle, which is 60.3 degrees. And that's roughly 1.7. Let's see what the calculator said. 473 times 0.7, times the square root of 3. Where's the square root here? Oh, God. Can't see it in the dark. 1.732. That's the square root of 3. I know that. So roughly 820. So that's 820. I don't know why I put this one. 820. The angle is 60.3 degrees volts RMS. If you want to find VBC, subtract 120. VCA, subtract 120 from the other one. And you have everything that you need.